Good afternoon, students. Today we are going to cover chapter number 3, pair of linear equations in two variables. It is a quick revision, chapter number 3. In this chapter, we'll discuss about representation. There is a two types of representation. First, algebraic and geometric. Again, the solution of linear equation in two variables. There are two types of solutions, algebraic and graphical method. In algebraic method, there are more two sub methods. Nature of lines will discuss about the intersecting, coincident and parallel lines. We'll discuss the method for solving the linear equation by algebraic methods. So in that we'll discuss about substitution method and second elimination method. The fourth is type of equations. Simple, reducible. There are two types of problems, which one is a simple one and reducible. Then coefficient interchange, third type. After that we'll discuss the word problem and graphical solution also. So let's start with the representation. So pair of linear equation in two variables are represent like ax plus by plus c equal to 0. This is a linear equation in two variables. It represents a straight line. If the a, b and c, these are the real numbers and x, y are the variables, and this combination is called linear equation in two variables. When these coefficients are different, then we get two different types of equation. The standard form a1x b1y plus c1 equals to 0. The second one a2x plus b2y plus c2 equals to 0. These two represent pair of linear equation in two variables. Now we'll discuss about the geometric representation. So geometric representation, a line, this will represent a straight line and this will again represent another straight line. So the graphical representation is a two different straight lines. This is algebraic equations and graphically we'll discuss later on. Now we'll discuss about the nature of the lines. The nature of the line is decided by the coefficients of the linear equations. Suppose a1x plus b1y plus c1 equals to 0, a2x plus b2y plus c2 equals to 0. Then if these coefficients, the ratio of the coefficients a1 upon a2 is not equal to b1 upon b2, then the lines are called intersecting. The lines are intersecting. If the ratio of the x coefficient is equal to ratio of the y coefficient is equal to the ratio of the constant term, then the lines are coincident. If the ratio of the x variable is equal to ratio of the y variable, which may be equal or may not be equal c1 upon c2, then this condition is called parallel lines. So what is the solution? If the lines are intersecting in a single point or in infinite points, like coincident condition. When the lines are coincident or intersecting, in that case the lines have solution. Here we say that the lines have unique solution, and in this case the lines have infinite solution, infinitely many solutions, and these two types are also called as consistent. The lines of this type, the lines which having either unique solution or infinitely many solution, in that case the two types of these lines are called consistent. And when there is no solution, the lines are parallel, never intersect each other, then the lines called inconsistent. So there is a question, check whether the lines are consistent or inconsistent. If the lines are intersecting or coincident, then the lines are consistent. If the lines are parallel, then the lines are said inconsistent. Let's move to the next point. Method for solving the linear equations in two variable. So there are, for algebraic methods, there are two methods. The third one, which is deleted from the syllabus now. The first one is substitution method, and second one is elimination method. So substitution method, we replace one variable by another, and in elimination method we equate their coefficients and then we solve the equations. We'll take some examples related to substitution method and elimination method also. Now the fourth one is types of questions. So which type of questions may be asked in exam? So there are simple type of equation, solve the simple equations by substitution method or elimination method, or there may be a headline only, solve. Then there is a second type, reducible type, 1 upon x, 1 upon y, then we have to convert them into the standard form. Coefficient interchange, the coefficient of the variables are interchanged, and then we have to solve the question. So we'll discuss the word problem and this type of few questions now. So most common question which is asked for linear equation in two variable is a graphical solution. So first question we'll discuss, draw the graph of 2x plus y equal to 6 and 2x minus y plus 2 equal to 0. Shade the region bounded by the lines and x-axis. These lines and x-axis, the region bounded by these lines and x-axis, we have to shade that region. Also find the area of the shaded region, and whatever the shaded region will get, we have to find their solution also. So we'll discuss this graphical solution now. Here first we have to find the coordinates of the point. So 2x plus y equal to 6. We can take y equals to 6 minus 2x. In this case we can assume the points. We have to take always 3 points, at least 3 points we consider, 2 for drawing the points and third point is for the checking. It's a cross check of the lines. So first x, y and xy, these are the coordinates. So 6, so we'll go by 1, x is equals to 1, 2 and 3. If we put x equals to 1, 2 1s are 2, 6 minus 2 becomes 4. If we put here 2, 4, 6 minus 4, 2. If we put here 3, 3 to the 6, it becomes 0. So we get the coordinates as 1, 4, 2, 2 and this one is 3, 0. So these coordinates for the drawing this line. Now we'll solve the similar way the second equation. 2x minus y plus 2 equal to 0. It becomes 2x plus y. 2x plus 2 equals to y. Again we'll consider 3 points to solve these equations. So x, y, x comma y. In this case, if we put x is equals to 0, so it becomes 2. If we put 1, 2 ones are 2 plus 2, 4. If we put here 2, 2 is a 4 plus 2, 6. We'll get the points 0, 2, 1, 4 and 2, 6. Now we have to plot these points on the x-axis. Always remember, we must take the points which can be drawn on the x and y axis, so that all the 3 points will be covered. Let's draw the graph of the equation. If we take x and y axis, do remember that the x and y axis must be taken on the graph paper only. Here for reference I am drawing a graph. The point of intersection is denoted by 0, while these points at a regular interval always write on the below the line of the x-axis. Below the line you should mention these points. Here also 1, 2, 3, 4, 5. Now this is the negative direction of x-axis, we will take them as a negative. This is the negative direction of y-axis, we will take it as a negative. This is a positive sign. We must mention the scale here. Scale we have to mention. Scale 1 centimeter is equals to 1 unit on both the axes. So we take on both the axes scale like this. Now we'll plot the points on the line. So we can take the points, suppose here up to 5 only. So I can change the coordinates also. If I am taking the 6th one, then the graph, it may go outside of the graph. So first point that we have taken y. So points y, equation was y equals to 6 minus 2x. The first point that we taken is 1. So 2, 6 minus 2, 4. So first point was 1 and 4. So just locate the point 1, 4. So 1, 4 we locate here. Then the second point 4. 6 minus 4, 2. So again 2, 2 is the second point. Then we have taken x equals to 3. 3 to the 6. 6 minus 6. That is 0. So 3, 0, that is the x coordinate. And we'll draw these points by a straight line. So we'll draw a line by joining this point. We must name the points we drawn, that is 3, 0, this point is 2, 2 and this point is 1, 4. We must mention the name of the line on this line equation also, that is 2x plus y equal to 6. Now we'll go for the second equation. Y is equal to 2x plus 2. If I consider x equals to 0, so x equals to 0, it becomes 2. So 0 comma 2 will be the first point. So 0 comma 2 means this is our first point. Now I consider x equals to 0, so y becomes 2. If I consider x equals to 1, so 2 plus 2, 4. So 1, 4 will be the second point, which is the intersecting point. And if I consider 3 to the 6, though it will be larger, so we can consider x in place of x, we can consider minus 1. So minus 2 plus 2 becomes 0. So minus 1 and y coordinate 0 means this point will be there. So we have to draw again one line which is intersecting. See, these two lines are intersecting. And now thus we will shade the region that we got here. So shade the region is here like this, and this form a triangle. Now see this point, the name of the point is minus 1 0, name of this point is 0 comma 2, and this point is already we mentioned 1 comma 2, and the line, name of the line 2x minus y plus 2 equal to 0. Now we have to find area of the shaded region. Now area, so for area, half base into height. Why? Because this shaded region, these lines and x-axis form a triangle. So we'll consider this as a base. So base 1 unit, 2 unit, 3 unit, 4 units. So base is a 4 units. And what about height? Height is a perpendicular drawn from vertex to the base. So this is a height, that is y coordinate, and y coordinate is 4. We'll solve this. 2 ones are 2 twos are. So answer is 8 square units. So area of shaded region is 8 square units. So this type of question may be there for 5 marks. We'll discuss one more question. The second question is related to the algebraic methods. So algebraic methods, I discussed that interchanging the coefficients type. So there is a question as 21x plus 47y is equals to 110, and second one is 47x plus 21y equals to 162. In this question you can see the coefficients of x and y are interchange. This is called the interchange the coefficient type. This is a special type of linear equation in which we have to add these two equations first. We'll get the equation that we'll name as a 3, equation number 3. So we have to add these two equations. We add, then this 7 plus 1 8, 6 plus 2 8, again 68y, and this 2 7 272. Always remember, whatever the addition will get, it will be easily divisible by the coefficient of x and y. So this divide by 68, we'll get x plus y is equals to, now there is a 68 and here is a 272. 8 4s are 32, so just take it. 8 4s are 32, 6 4s are 24, 24 plus the 27 means 68 4s are. This is equation number 3. We'll discuss now the further solution. Now we have to add this 2, then we have to subtract this 2 also. So we'll subtract now. 47x, 21y, 162. If we subtract them, we'll get the minus 26x, again plus 26y. Again here the subtraction will be minus 2 minus 0 0, then 6 minus 1 is 5, and this minus 52. If we divide by 26, we'll get minus x plus y is equals to 52 upon 26. 2's, that is minus x plus y is equals to minus 2, which is our equation number 4. Now you can see these two equations are now simplified. So we'll get the answer. This is x plus y equal to 4, and the second equation minus x plus y equal to minus 2. In this case, this is equation number 3, this is 4. Their coefficient are different, we'll add them, these two terms will cancel, then we'll get the answer. So 4 minus 2, 2, we got the value y equals to 1. And if put this value y equals to 1 in this equation, then we'll get x equal to 3. So this is called the algebraic method of solving the simultaneous linear equation in two variables when the coefficient of variables are interchange. This type of question may be asked for 3 marks. Now we'll discuss one more question related to the algebraic methods. In the starting only, we discuss about the nature of the lines. Related to that, one question in the previous board exam asks, find the values of alpha and beta. Find the values of alpha and beta for which the system of linear equations now linear equations are given as 2x plus 3y is equal to 7, and second is 2 alpha x plus alpha plus beta y is equal to 28. And the question is has first question infinite solution. If they have infinite solution, we have to find alpha beta. Second, they have unique solution. So if they have unique solution, again we have to find alpha beta. And C, they have no solution. So no solution, in that case we have to find alpha beta. So this type of question is asked in the previous board exam. We'll discuss now the solution. As this equation, system of linear equation has infinite solution. So condition for infinite solution. We'll discuss infinite solution. Condition for infinite solution is a1 upon a2, b1 upon b2, c1 upon c2. So this is a1, this is a2, this one is b1, this is b2, this is c1, this is c2. Now we'll find the solution for this. 2 will get cancelled. 1 upon alpha is equals to 7 1s are 7 4s are. So 4 is equals to alpha. We got the solution. Alpha is equals to 4. So in this way we got the solution alpha equals to 4 when the condition is infinite solution. We can solve for the beta also. We'll take the first and this second question. This 3 upon alpha plus beta is equals to 1 upon 4. 7 1s are 7 4s are. If this is a 4, we'll cancel this. 3 into 4 is equals to 4 plus beta. So 4 3s are 12. 12 minus 4. So we got the value of beta. 12 minus 4 as 8. So again we got the solution that alpha is 4 and beta is 8. In this way, the first condition for infinite solution, the values of alpha and beta are 4 and 8. We'll discuss now the second condition. The second condition is has unique solution. When the equation have unique solution, in this case also we can find unique solution condition is what? a1 upon a2 is not equal to b1 upon b2. So we'll take a1 as 2, a2 as 2 alpha, not equal to sign as it is, b1 3 and b2 alpha plus beta. Now we'll solve this 2 in bracket alpha plus beta is not equal to 3 into 2 alpha. Again, we'll solve this. 2 alpha, 2 beta not equal to 6 alpha. So it becomes 2 beta is not equal to 6 alpha minus 2 alpha. 2 beta is not equal to 4 alpha. 2 ones are and 2 twos are. So we got the value beta is not equal to 2 alpha. This is a solution when the lines are have unique solution, means intersecting line. We'll go for no solution. Now for no solution, the condition is a1 upon a2 is equal to b1 upon b2 and is not equal to c1 upon c2. So a1 is 2 upon 2 alpha, b1 3 upon alpha plus beta, and this c1 upon c2, that is 7 upon 20. So we'll solve this and this one. So 1 upon alpha is not equal to 1 upon 4. So 4 is not equal to alpha. The first condition. We'll solve this. Then 3 to the 6. Then we'll cross multiply 2 in bracket. We can consider these two also. If for simpler, we'll get direct answer. 3 into 7 manza and this 7 forza. Here alpha plus beta. What is the value of alpha? Alpha is not equal to 4. So 4 3s are 12. Alpha is not equal to 4, we'll put here, plus b. So beta is not equal to 8 will be our solution. So in this way we can find the solution for the different conditions. Let's move for the one more question. The word problem related to this type of question is half of the difference of two numbers. Half of the difference of two numbers. Suppose two numbers are x plus y. Half the difference of two numbers is 2. And difference, so we have to take the subtraction. And the second condition, the sum of the greater number. Suppose this is the subtraction, so this must be the greater number. The sum of the greater number and twice the smaller number is 13. Then find the numbers. We'll solve these two equations by substitution method. So see this, x is equals to 13 minus 2y. We got the equation 1. We'll put this here, x minus y. Now here 2 goes that side, so it becomes 4. X is 13 minus 2y minus y equals to 4. This 13 minus 4 equals to 3y. 9 equals to 3y. So y becomes 3. And we put this value here. So we'll get 13 minus 6, which is equals to 13 minus 6 equals to 7. So these are the numbers and we can cross check them by putting the 7 and this. Suppose we subtract this 7 minus 3 is 4 and we half it, divide by 2, so 4 upon 2 will get 2. The sum of the greater number, that is 7, twice the smaller number, 3 2s are 6, 6 plus 7 will get the 13. This one is called as a check. So we check also the solution. Now we'll discuss the word problem related to father's age. The father's age is 3 times the sum of the ages of his two children. Sum of the ages of two children is given. The father's age, let father's age. So we have to consider present age only. So present age, father x year, and the sum of the ages of his two sons. two sons. This condition is very important. So suppose we are consider that age as a y. Father age is 3 times the sum of age of his two sons. So father's age is x, 3 times the sum of the age of his two children, 3y. So we got the first condition. Now second, after 5 years. So let's consider after 5 years. So father's age, after 5 years father's age x plus 5, and the son's age, yes, son age y plus 5 because two sons are there. So 5 of the first and 5 of the second, we have to add 10 here. This is the turning point of the question. After 5 years, age will be twice the sum of the ages of children. The father's age after 5 years x plus 5 twice the age of the children's. We'll solve this. X plus 5 to y plus 20. So we can solve, in place of x we can put this 3y, again substitution method. So we'll get y equals to 20 minus 5, y equals to 15. So son's age, the sum of the ages of the son, 15. And what about the father? X is equals to 3y, 3 into 15, that is 45 years. So father's age is 45 years and son's age is, sum of the son age is 15 years. We can cross check this by again substituting these values in the given condition, and we can check here our answer. So thank you students. Many more questions are like this for the chapter pair of linear equation in two variables. Thank you.